Thank you to Ross Industrial. Thank you all for being here. Appreciate it. Too kind. This is Matt said, Max Falcone with PushCorp. It's kind of funny. So like I got this vice president of sales engineering. Everybody's like, what the heck is sales engineering? Well, the reason is I've been an engineering manager for a long time. Came to PushCorp. This is my first ever sales role that I've had. And I'd show up to plants to help people solve some sort of robot problem, you know, give them a business card. They'd look at it and then they look at me and like, why are you here? Like, so we had to add engineering onto the end of sales. Otherwise I had no street cred when I go in to help people. So just in case you guys are wondering. So PushCorp, we started in 1993. For those of you that don't know us, born out of a college doctoral thesis research project, the active force compliance device. So it was patented through the University of Texas, Arlington, where Dr. Skip Berlbacher went, our original founder. While he was there, he made friends with 3 other guys, and together they put together the force compliance device. Ate tuna and beans for several years till they picked up an SBIR project and worked out of our CTO's garage, much to his wife's chagrin, and built a company around essentially what was an idea and a college project. So here we are, what would it be, 32 years later, as a company. We were acquired last year by Walter Surface Technologies out of Montreal, who is a big player in the metalworking industry. So super excited and proud about that. And we've recently come up with kind of a new identity, right? So like the grit, the relentlessness, the purpose, these are all things that we're really proud of and kind of builds our persona as a company. We want to help people. We want to tackle tough jobs, but we want to build good, solid equipment that just can last the test of time. So I was telling somebody in our booth the other day, they asked us, do you repair your own products? I said, yes. Actually, 2 weeks ago, we received a spindle that we sold in 1998, repaired it in 3 days, sent it back to the guy, and they were back up and running. And, you know, we had to make a couple components. We still have the drawings. We got our own CNC machines, but we're willing to help. We want people to be up, running, and we stand behind the product. So what do? A lot of what we've done is material removal. So we take a human and we take a human who's using his arms, holding some kind of tool, doing some sort of process, and we figure out how to do that with a robot. So I don't like to say people are getting replaced, but we're taking somebody who's doing a tough job, dirty job, demanding job, and in most cases, giving that person a technical career, right? Because that robot doesn't know anything. You know, a robot's the dumbest thing in the world. You've got to tell it what to do. You've got to get it the right tools. But for most parts, robots don't understand process. So in grinding, you can teach somebody the science of grinding, but much like welding, painting, there's art involved. And the art of grinding is not simple, okay? So we've created this force compliance device, which is an appliance that goes on the end of the arm of the robot to be able to control the force in any orientation as a robot's doing the job. So simply, I love this graphic. So typically, if you've got a wheel on the end of a robot, you've got to follow some contour shape. You're programming a whole bunch of points along that shape to have that wheel remain in contact. But as that robot moves along that shape, the more accurate you need it to be. In most cases, the slower the robot needs to move or the more feedback you need to have. The idea with the force compliance device and its own movable carriage is you program a lot less points. So your robot programs become a lot less complicated. And across those 2 points, the force compliance device is handling all that variation, keeping a constant force up along the surface. So the thing with the active compliance device is that it has a suite of sensors inside of it. It has its own microprocessor. It's got its own set of valves. It's got a linear potentiometer. It's got an accelerometer. And all these things work in concert to do what the compliance device does, okay? So that you can grind all the way around a pipe. You can grind in a linear straight line. You can grind a spiral weld. you can grind, you can sand a guitar, you can polish a knee joint, you can do all these complicated tasks that are very tactile, a lot of movement, and control with a high sense of precision that a human would normally do that, right? For a robot to be able to do that, and you look at even like a force torque sensor trying to do those things, usually with a force torque sensor, you have to move a lot slower because the part that you're using all 6 degrees of freedom of a robot to adjust ounces out at the TCP. The faster you move, the part that you adjust it for is further behind you, right? With the compliance device, we're doing everything closed loop right at the contact point. So we're able to do these things very quickly. So when we started in 1992 with the active compliance device, we had something we called the FCU, the force control unit that connected to the AFD. I feel like I'm a DOD guy now, but essentially, so there's this little processor that's in there. It would get digital and or analog commands from some sort of device, usually a PLC, and send that information to our AFD over RS-485, and the AFD would do what it was told until it was told to do something else. Okay, and this was, like I said, all digital I/O, 24-volt I/O, with analog if you wanted full control of the force. Otherwise, you could do like a binary sequence of the digital I/O through that. So these were super simple to deploy. Any guy in any factory with a voltmeter could debug them. One of the decisions that was made at the time, you can argue it was good or bad, is that it was a single phase 100 to 220 volt power that went to it. So we didn't meet any of the low voltage directives that ended up coming out. But we sold this device up until 2018. From 1993 to 2018, there's literally thousands of them across several different industries. As we started coming into the world of field buses, in 2018, we released the 3rd generation of the active compliance device, the AFD 310, 620, 1240. And with that came with a new product called the FCU Flex. The FCU Flex got rid of the analog, which, looking at it, was one of the best things we did in 2018, because as we went into COVID, all those analog devices that we were using were non-existent. Like, we were hurting for people that needed replacement FCU 1000s for the previous generation. So, but with this, like I said, we kept the digital I/O, got rid of the analog, but we added things like Field Bus now. So you can use Profinet, Ethernet IP, DeviceNet, and EtherCAT on our device. Still, this connects to the AFD. You tell this what you want to do. This tells the AFD, and they do a little handshake, and that's what they do. Okay. But we also added this little Ethernet programming port on there, and we added a PoE capability to this. It didn't work well. So we got rid of the PoE capability on this device and added PoE through a separate device now, and we're doing a passive PoE. So when you go into really what I'm here to talk to you all about is that this device is great for your standard robot and PLC programmers. They understand field bus. You got a FANUC robot, you create a device on rack 89, you set up your I/O, life is good. Any robot guy can handle that. But with the digital I/O and the field bus, PushCorp told you how to use the device. We said, this is it. This is the field bus. This is the map. This is what you get to use. No more, no less. This is it. So with this came a little bit of a change in the mentality at PushCorp, where now I'm going to concentrate on the UDP JSON that we have, but we also have the ability to do a TCP IP. If you don't need a lot of speed and you want that packaged layer in there, you can do TCP IP. We also have a web interface available where if you want to build an HTML type interface, we've got an HTML type interface available to control units. Like, you literally open up a Google browser and type in commands, and it's just a white screen, says Google, and gives you PushCorp AFD command responses. But with the UDP, you don't need this device anymore. This thing's $3,400 list. That goes out. Now you just took $3,400 out of the price of your system. But what do you need to do? Now you got to write something to handle the JSON, right? So write some sort of parsers, some code to do that. But we completely open the hood. We give you access to everything. You get to see the accelerometer. You get to see the linear potentiometer. They're not documented. And if anybody wants it, you know, Jacob's doing a lot of work on this. Like, we'll give you access to the valves. We'll give you access to the gains. And so the idea is, like, we're completely opening the hood, and you can build a system to do whatever you need to do. Again, PushCorp, a lot of what we've been doing is material removal, but within the last 5-6 years, we've done a lot of projects that are non-material removal. We've done a laser welding project. We've done a steaming project. We've done a lot of different things, insertion, placement, a lot of different projects that aren't material removal because somebody didn't want to go through all the complexity of programming a force torque sensor when they only need one axis of control. Okay. But what comes with this, and what I'm hoping to inspire here in Dave's conversation with Picnic, as far as all the drivers that they've written, the work that Jake's doing, Adam's doing, and a lot of other universities, is this is pretty complicated for the average robot guy on a plant floor to take in, write these codes, write these programs, and deploy them. From the PushCorp side, we never know how our equipment's going to be used. Like, there's so many NDAs. I get buried in NDAs. I'm signing like 3 to 4 a week. It's nuts. It's like, this is a blacksmith thing. We've been doing this since 1300s. What are we NDAing here? But that's just the world we live in. So really what we're looking to do with this is give everybody access to a device so that you can use it the way that you need to use it, the way that it needs to be effective, use the features, program the features, get the data that you need, and not be stuck to our predetermined bitmap, right? So that's the access. So like I said earlier, we've got a suite of sensors inside of the device that are in there to do what it does. So force, position, acceleration, the gains. We've got a feature called soft touch where you can essentially meter the amount of force based on the position of the carriage, so you can feather into a grind so you don't create a flat spot on something, right? So we give you access to all this stuff. You can change IP addresses, you can get names. All these things are in there. It's documented in our manual. It's available to everybody today. But again, there's things that aren't documented on here that if you reach out, our technical managers back here, Laith, that we can give you access to. If you got a reason, you know, we're not going to stop you. We're going to let you know very bad things can happen very fast. But again, we're all here doing research. We're all here learning. We're all here creating a new tomorrow, right? So we don't want to hold anybody back. So looking at the ROS family, right? Everybody that's on the family tree here, from end users all the way down to researchers and everything in between. We're looking to create new, robust, streamlined, application specific. So right now, when we build an AFD, as I said, we don't know what it's going to be used for. So we have a very vanilla set of gains in there. So if you need to do fine wood sanding on a guitar, or you need to grind welds, our gains are set to be able to do all of that, right? But if you know that you're going to be grinding on a huge casting at 50 pounds of force, you probably don't need 1 Newton of resolution, right? So the way our system's set up today, you're getting that resolution whether you need it or not. So how much is that slowing you down? How much is that keeping you back? So really what we're looking to do is to work with this community, work with these people, understand how does the system need to function for what you're looking to do, okay? And we're looking to work with people to build these maybe application specific. Everybody uses like the recipe term, but really we're looking at how do we build these solutions so they're more modular, right? And we make a marketplace of these different profiles. And this is one of the things that I think I was talking to Adam last night about this, and I used the analogy of college students, essentially weaving college students out instead of weeding them out, right? So we want to weave them in instead of weed them out. And that's kind of what we want to do with our hardware as well. We want to weave it into solutions, right? We don't want to force it in there. We want to make it part of the whole entire solution, not just a piece of hardware that it does most of what I want. We want to do everything you want, right? So that's the idea. So Iowa State was nice enough to provide me some of this, provide me these videos here. Let's see if I can get them to play. All right. So you see the data there streaming as they click around. There's different modes they can go in, streaming data. And again, this is all the data that's coming from our sensors. So it's a little hard to read. I tried blowing it up, but I'll tell you kind of what those things say. So it's like actual force, actual position, command force, command position, payload weight. So it actually knows how much weight is hanging off the carriage. That's something it does automatically. Acceleration gravity. So that's that raw data from the accelerometer in the device. So now you can almost see, you can capture vibration, you can capture a lot of these other things as a stone wheel breaks. You know, what does that look like? So tool coordinates, what else do you have in there? And then control mode, because we can do force mode, position mode, a contour mode. But you can see all the data streaming coming into the device. And then what you can do is log all that as well, right? So all that data is available to you. No reason you can't put it out in a comma separated variable. Now what we can start doing is we start learning and building math models for things to get better. We can monitor abrasive wear. We can monitor changes in when something glazes over. We can look at all these things, right? So here's another video that shows the robot with the equipment on it responding to the commands, right? So this isn't something that's built in a simulator. This isn't anything this is real. It's available today. And like I said, this is all free with our equipment. All this is documented in our manuals today. We just don't do a good job of talking about it. So that's why I'm here talking about it. But anyways, you've seen one graph, you've seen them all, but really appreciate Iowa State sharing this and letting everybody know they're doing some great work out there. But from my experience, and I'm sure Jake and soon Adam, they can share their feelings and how responsive they feel everything is. But we're really happy to see people taking what we put together and actually putting it to use. So that being said, there are some commercial deployments of the technology, and people who have taken this, gotten stripped off the Ethernet IP, the Profinet layer, talking directly to it and incorporating it directly into their software packages. So Gray Matter with their scan and plan, Titan Robotics demo booth that's running here at the show, Sweary down at the bottom with the Fisher Castile project. There's a lot of good stuff going on there where people have taken this and already started implementing it into their software, made it part of their hardware architecture. So Titan also provided some information for me here to where their system, we took these captures off of their, let's see here, there we go. So we took these captures off of their system that they're running here. So this is like the simulation environment that they're running. When they have a little bit of the compliance device is in a no mode, it goes to an active mode. So you see all of a sudden it gets the force command very quickly. It writes, and you can see where it starts to make contact with the part. So we had it simulation, graphing, and then the actual. I couldn't get the actual video up here. I'm not PowerPoint savvy enough, but you can see the actual force, and so what they're targeting force, the actual force, and then the flange position down at the bottom to see where it's at. So like here is the real grind of what they actually ran. And again, no field bus, everything's directly to the robot, real time, near real time for an update rate, right? So this is scan to plan directly into the system, gathering the data. They take that data and they iterate and improve on the next cycle. So not super exciting. Everybody's seen But, you know, kind of the comparison for a lot of folks out there, you know, when I talk to folks, they don't know like where did he sit and where they go. So I put this little chart together, and really this UDP interface that we put together, this JSON, really we're looking at it as the full custom control of our device, right? So we're excited to see what people do with it. We're excited to see where it goes. We've got equipment, I believe, in 14 different research institutions now, whether it's colleges. We've got stuff at ARM, we've got stuff at Norton St. Gobain's lab, and we got stuff at 3M's lab, Walter's lab. PushCorp runs 2 labs out of Dallas. We got stuff at Sweary, Iowa State, Ohio State, Missouri S&T, Toledo. I mean, we're really supporting academia. So if somebody's interested in some equipment, if somebody is looking to do some research in this area, please talk to me. Happy to support what you're doing. So, P.S. I talked a lot about the AFD, the force compliance portion, but we worked with Cole Morgan to also create a UDP interface for the servo drives. So you can get motor temperature directly, you can get motor amperage directly, you can get motor speed directly. So PushCorp makes a whole line of servo motor tools, and now we're working to provide that data as well. So now we can get a whole nother feedback loop into the material removal process. Okay. Max Falcone, PushCorp, thank you for your time.
Excellent, Max. Thank you. Any questions for Max on the work they're doing over at PushCorp and maybe what's next and coming up? Yes, Dr. Munoz.
It's really amazing what you have achieved with a very complex problem of force control. I'm just wondering, I remember the old times when we were trying to implement compliance and force and calibration. We always had this problem with the impact. This is a direct force, infinite force in a very short time. And it was always the problem on making the control to achieve stability during the impact. And the compliance, the device that you are proposing is actually solving part of the problem. Nevertheless, in the simulation, we have always to deal with these kind of non-linearities. How are you managing that stuff?
So big portion of that is why we're such big proponents of a pneumatic system. Having a pneumatic system and not a directly coupled mechanical system in there helps a lot of that absorption of that. The other thing we've done is we've got a special set of cylinders that allow a certain amount of blow-by, if you will, with a zero friction. So we've worked with THK, come up with a specific set of bearings that have very low stiction, so the breakaway force is very low. We have almost a zero friction cylinder setup, and we've been able to handle a lot of that mechanically. And then what's left is within our gains that I was talking about in the software level with the suite of sensors. So everything has to be firing together to get, you know, that perfect adjustment. And for the most part, PushCorp has concentrated in big, heavy, dirty for a long time, right? So we're in foundries, we're in automotive plants, we're in aerospace, we're in all these big plants. So we've done a little bit of a trade-off of probably over-engineering because, again, where we're at is a little tough. And that's where I'm looking for, if you've got a specific use case that needs a finer motion, that's what we're looking to talk to now, right? And maybe what we have is excessive for some applications and maybe it's not enough for others, right? But that's how we've handled that, is through the suite sensors.
I guess I have a question. Since I have you on stage, is there a GitHub repo in PushCorp's future?
I don't even know how to spell GitHub, but I'm hoping so, right? So with Lath in his position, we're trying to figure out how do we do that and how do we support better, right? Every day it's about how do we do things better. It's not something we've done. Lester, our original CTO, he retired in January, so we lost a big portion of PushCorp history, but also the guy that would have known how to do all that. So now we're trying to build that, but we're also looking for good partners to help us get to that next stage.
Yeah, I can, you probably have time for one more. Roger, get your hand up first.
Thank you. Max, with all the parameters you can pull from the device now conveniently, do you have thoughts of putting an SDK together just to interpret, analyze, and
So that's the big, that's the big question, right? So do we do an SDK? Do we do an API? Do we do a ROS package? What does that look like, right? And I don't know how many more acronyms we can put into the PushCorp family, but
you got UDP already?
right. I mean, we got to do something, Roger, right? We got to do something. We just don't know what that something is. And the way things are going, it's kind of like the way things are going, we got to do something. There's so many people doing different things, right? And it's even like the field bus thing where we're like, is EtherCAT going to win? Is Profinet going to win? And now all three of them exist, right? So do we need to do all three? Do we pick one? If we go with the ROS driver, what do we do with people that aren't using ROS? If we go the other way, right? But like, I think with ROS it makes sense because we've got these layers. We were talking about this last night, is that interconnect, that connective tissue that brings everything together. But yeah, we want to do something. We're just not sure. And that's where we need to start figuring that out sooner than later.
Excellent. Thanks, guys. That we gotta
Awesome.
introduce the next speaker.
Appreciate you.
Thanks, Max.
Thanks, everyone.
Appreciate it.